Greetings, my name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Today, let's talk about fractions, something more useful than you might realize. Fractions show up in everyday life, whether it's calculating a tip at a restaurant, adjusting a recipe, or dividing costs with friends. Understanding fractions isn't just a skill for school. It's something you will use frequently in your daily life, at work, and when managing your money. First, a fraction is a way to represent a part of a whole. It is a mathematical expression that shows how many parts of a certain size make up a whole. The key here is we are talking about something whole and dividing it into equal size parts. When we divide this pizza into 4 equal slices, each slice is 1 out of 4 parts, or 1/4 of the pizza. This is a fraction. It tells us about 1 part of a divided whole. A long time ago, fractions were written out in words, and division was written as what we know as fractions today. Centuries ago, mathematicians used a horizontal line called a vinculum to represent division. The number on top showed what you were dividing, while the number below showed the size of each part. When the printing press came along, common fractions were written this way, and it became the standard. So, when you see a fraction like 3/4, you are actually looking at a division problem. 3 divided by 4. Understanding fractions as division can make them feel more practical and relevant. Think about splitting a bill among friends. If the bill is $120 and you're sharing it with 2 others, each person's share is represented as 120 divided by 3. That's $40 each, or 1/3 of the total. Fractions also help in many other areas of life, such as scaling a recipe, like when you want to halve or double a dish. Now that we know a bit about the history of fractions, let's break down what each part means and how they work together. A fraction represents division, a way of showing how many parts we are considering and the size of those parts relative to a whole. In a fraction, we have 2 main parts, the numerator and the denominator. The numerator is the number on top, indicating how many parts we have or are considering. The denominator, the number under the vinculum, shows the total number of equal-sized parts that make up one whole. In this case, we are talking about 3 equal parts of sugar. The denominator tells us how many equal parts a whole cup has been divided into. Here, it's divided into 4 equal-sized parts. Let's see how this looks in different ways. One way to visualize fractions is by using diagrams, such as divided shapes or fraction bars. This approach lets us see how a whole can be broken into equal parts and helps you visualize fractions and their relationships. As we can see, the more parts we divide the whole into, the smaller each part becomes. Half of a circle is larger than a third, which is larger than a fourth. Candace cuts a pie into 8 equal slices. One friend eats 1 slice and another friend eats 2 slices. What fraction of the pie did the second friend eat? Let's draw a circle cut into 8 equal pieces to represent the pie. Each slice of the pie is 1/8 because she cut the pie into 8 equal pieces. I will shade in 1 piece to represent the 1 slice her friend ate. Then I shade in 2 pieces to represent what the second friend ate. Counting the pieces in this picture, we can see that the second friend ate 2 out of 8 pieces, or 2/8 of the pie. How much more did the second friend eat? Let's compare the fractions 1/8 and 2/8 by looking at the diagram. It shows us that 2/8 is 1 part greater than 1/8. 2/8 is twice as big as 1/8. The second friend ate twice as many slices, or 1 more slice. If a third friend eats 1/4 of the pie, how many slices is that? How does 1/4 compare to 1/8 and 2/8? To answer these questions, first I divide the same circle into 4 equal pieces to represent the denominator of the fraction 1/4. Then I shade in one of the 4 sections to show the amount of the pie eaten by Candace's third friend. Notice that shading in 1/4 of the pie is the same as shading in 2/8 or 2 slices. Therefore, her third friend ate 2 slices as well. 1/4 is twice as large as 1/8, but the same as 2/8. If Candace shared a total of 5/8 a pie among friends, what fraction of the pie is left? Looking at our diagram, we can count the 5 slices of pie that were eaten by Candace's 3 friends. There are 3 parts of our diagram that were not shaded, representing 3 pieces of the pie left. 3 parts out of 8 parts, or the fraction 3/8, represents the amount of the whole pie left. Using a diagram allows us to visually explore fractions, making understanding their relationship to other fractions as easy as, well, pie. Here is another example. A soup recipe requires 1 cup each of carrots and celery. If Kayla added 1/2 cup of carrots and 1/4 cup of celery, how much more of each ingredient is needed to reach 1 cup? First, represent each vegetable using a fraction bar. I divide the first bar into 2 equal pieces because the denominator of the fraction representing carrots is 2. We will shade in 1 piece because the numerator is 1. This shows having 1 part out of 2 equally sized parts, or 1/2. To see how much Kayla needs, look at the unshaded part. In the diagram, 1 more part is needed to shade in the whole bar. Each piece represents 1/2 cup. Therefore, Kayla needs 1/2 cup of carrots more to have 1 whole cup. Now let's do the same for celery. This time the bar is divided into 4 equal pieces because the denominator of the fraction representing celery is 4. I shade in 1 piece because the numerator is 1. This bar represents 1 part out of 4, or 1/4. To see how much more celery Kayla needs to have a cup, we again look at the unshaded part. In this diagram, 3 parts are needed to shade in the whole bar. Since we need 3 parts, the numerator is 3. The bar is cut into 4 equal-sized pieces, so the denominator is 4. Therefore, Kayla needs 3/4 cup of celery more to have 1 cup. If Kayla decided to add another 1/4 cup of carrots, how much total carrot has she used now? How does this new amount compare to the 1 cup required? Kayla started with a 1/2 cup of carrots. However, to add an additional 1/4 cup, we need to understand the measurements using the same sizes. Therefore, we break the original rectangle down into 4 equal pieces. Then we can shade in an additional piece of size 1/4 for the part she added in. Looking at the diagram, we can see she now has 3/4 cup of carrots. The new amount is less than the required 1 cup. 3/4 is 1/4 of a cup closer to 1 cup than 1/2 cup is. Suppose she adds another 1/4 cup of carrots. Now, how much carrot has she added in total? Has she reached or exceeded the 1 cup needed? Using the previous diagram, we shade in another piece of size 1/4. The diagram now shows she has used a full cup of carrots. She has reached the amount she needed for her recipe. If she mixed the chopped carrots and celery together, what fraction of the mix is carrots and what fraction is celery? Combining the cup of carrots and the 1/4 cup of celery together, we get the following diagram. Notice that 1 cup is the same as 4 1/4 cup pieces. Putting the pieces together, we see there are a total of 5 pieces of size 1/4. 4 pieces, or 4/5 of the total, represent carrots. 1 piece, or 1/5 of the total amount, represents celery. Using diagrams like these allows us to see what happens when working with simple fractions and can make fractions easier to understand. We can also show fractions on a number line. On a number line, the whole numbers are evenly spaced. When we place fractions on this line, we can see their relationship to benchmark fractions like 0, 1/2, and 1. For example, if you divide the section between 0 and 1 into 4 equal parts, each part represents a fraction. The first mark is 1/4, the second is 2/4, the third is 3/4, and the last mark reaches 1. This helps us understand how a fraction compares to another number. Here, 1/4 is a quarter of the way to 1, 2/4 is halfway, and 3/4 is 3/4 of the way to a whole. Now consider a chocolate bar. If we have 1 out of 8 pieces, placing 1/8 on the number line shows it's slightly above 0. Meanwhile, 4 pieces or 4/8 would land halfway between 0 and 1. By understanding these benchmark values, we can better visualize fractions and compare them to each other. Fractions aren't just about chocolates or number lines, though. Let's say you're splitting a $6,000 budget with 2 others. Each person's share is 1/3 of the total, and each portion is an equal part of the whole amount. Here, 1 is the numerator, showing 1 share, and 3 is the denominator, showing that 3 equal parts make up the total budget. In the previous section, we represented the questions regarding Kayla's soup using diagrams. Let's examine the same problems using number lines. A soup recipe requires 1 cup each of carrots and celery. If Kayla added 1/2 cup of carrots and 1/4 cup of celery, how much more of each ingredient is needed to reach 1 cup? The number line representing carrots is divided into 2 equal sections. This point represents the halfway point or the fraction 1/2. If I move from 0 to the 1/2 mark, I can see that I still need to go another 1/2 to reach 1 cup. The number line representing celery is divided into 4 parts. This point represents the fraction 1/4, the amount of celery Kayla currently has. To reach the 1 cup mark, we need to go another 3 sections, each of size 1/4, or 3/4. If Kayla decided to add another 1/4 cup of carrots, how much total carrot has she used now? How does this new amount compare to 1 cup? Like with the diagram, we repeat the process of dividing the same number line into 4 equal-sized sections to work with the 1/4 cup. We can see that the initial 1/2 cup of carrots is the same as 2/4. Moving an additional 1/4 towards the 1 means we have moved a total of 3/4 of the distance on the number line. With the number line, we can see that there is still 1/4 cup needed to make a full cup. Suppose she adds another 1/4 cup of carrots. Now how much carrot has she added in total? Has she reached or exceeded the 1 cup needed? Using the previous number line, she had 3/4 of a cup. Adding an additional 1/4 cup means moving along the number line an additional part of size 1/4 cup. This puts us at the 1 cup mark for carrots. She reached the 1 cup needed. If she mixed the carrots and celery together, what fraction of the mix is carrots and what fraction is celery? Using a number line, the space between 0 and 1 is divided into 4 equal sections to represent the denominator of 4. The previous question allowed us to see that Kayla had 4/4 cups of carrots. We move forward 1 section of size 1/4 to represent 1/4 cup of celery. 4 parts out of the 5 parts represents carrots, the fraction 4/5. 1 part out of a total 5 parts represents celery, the fraction 1/5. Heather mixes a cleaning solution requiring 1/4 of a spray bottle of cleaning concentrate mixed with 3/4 of a spray bottle of water. How much total solution does this make? We will represent each part of the mixture with a number line. The first number line represents the amount of cleaning concentrate. Because Heather needs 1/4 of a bottle, divide the line into 4 equal pieces, moving to the right from 0, 1 section. This shows the numerator and the denominator, 1 part out of 4 parts. The second number line will represent the part of a spray bottle filled with water. She uses 3/4 of a bottle, so this line is also divided into 4 equal pieces for the denominator. Move right from 0, 3 sections, representing the numerator. Since the parts are made up of the same size pieces, we can combine these into one number line with parts of size 1/4. With 1 part from the cleaning concentrate and 3 parts water, all 4 parts of the whole bottle are filled. Therefore, this makes 1 whole spray bottle of cleaning solution. Compare the amounts of concentrate and water in the solution. Which part is greater and by how much? By looking at the separate number lines, we can see that the part representing water is greater than the part representing concentrate. The water part is 3 times the concentrate part. If Heather decides to double the solution, how much concentrate and how much water would be needed? To answer this question, we could draw 2 sets of number lines to represent 2 times or double the solution. Counting the shaded parts for the concentrate shows she needs 2 parts out of 4 parts. Repeating the process for water shows she needs 6 parts out of 4 parts. Notice the size of the parts in one bottle did not change. What fraction of the double batch will be water and what fraction will be concentrate? The double batch is made up of 8 parts. 6 parts, or 6/8 of the double batch, will be water. 2 parts, or 2/8 of the double batch, will be concentrate. These examples highlight how understanding fractions helps people in a variety of roles make precise, informed decisions in their tasks. Using visual representations can help us compare and calculate using fractions. Here are some practice problems for your new skills. In my mathematical world, I have one little problem. Ramon works in logistics in a large warehouse. He said understanding fractions is crucial to his job. Help me understand these fractional situations. Ramon needs to allocate shelf space for different demand levels. If 1/2 of the shelf is reserved for high demand products, 1/4 for medium demand items, and 1/4 for low demand items, what fraction of the shelf is being used in total? If the high demand section needs to be reduced to 1/4 of the shelf to make space for new products, how much total shelf space would be available for new products? Ramon checks the inventory and finds that a storage bin is 1/2 full with product A and 1/8 full with product B. What fraction of the bin is filled in total? What fraction of the bin is empty? In the sorting area, packages are categorized by weight. 3/4 of the packages are lightweight, 1/8 are medium weight, and 1/8 are heavy. What fraction of the packages in total are medium or heavy? Due to increased demand, the sorting facility receives more lightweight packages, bringing the lightweight portion up to 7/8 of the total. If the remaining amount is shared equally by medium and heavy packages after the increase, what fraction does each type of package represent now? Ramon is tracking 2 shipments. One has traveled 3/4 of its total distance, while the other has traveled 1/2. How much further in terms of fractions has the first shipment traveled than the second? Suppose the shipment that has traveled 1/2 of its distance covers an additional 1/4. How much of the total distance has it traveled now, and how does this compare to the first shipment? Ramon distributes an inventory across 3 locations. 1/2 of the inventory goes to location A and 1/3 to location B. What fraction of the inventory has been distributed in total? Ramon has 6 hours for a crew to load a truck, spending 1/3 of the time sorting and 2/3 loading. How many hours are allocated to each task? If an additional 1/4 hour is needed for paperwork, how much total time is spent in hours and minutes? Ramon compares on-time delivery rates. If supplier A delivered 2/3 of their orders on time and supplier B delivered 1/2, which supplier has a higher on-time rate? If Ramon wants an on-time delivery rate of at least 3/4, by how many orders would each supplier need to increase their on-time deliveries to meet this goal? A warehouse has 3/4 of the space in use and 1/8 reserved for seasonal items. What fraction of the storage capacity is currently available and not reserved? If the warehouse plans to reserve an additional 1/4 of the space for incoming high-priority items, how much space will remain available after these changes? Ramon reviews an invoice where standard shipping costs $100 and expedited shipping is 3/2 the standard rate. What is the cost of expedited shipping? If a client has a budget of $400, how many shipments could they afford using each type of shipping, standard and expedited? Suppose the expedited rate increases to 5/2 the standard rate. How much will expedited shipping cost now? How many expedited shipments can be made within a $500 budget? Take a look and you will see a mathematical world around you filled with fractions. Remember, a fraction is a way to understand a part of a whole amount, representing a division problem. Fractions are made up of a numerator, showing how many parts you have, and a denominator, showing the total number of equal-sized parts that make up one whole. Using models can help you understand fractions, and now you can start seeing them in all sorts of everyday situations, whether you're cooking, measuring, or sharing something with friends. Next time you split something or measure a part of something, remember, you are using fractions. You might see the world a little differently through the lens of fractions.